Congrats on making it to Unit 2. You've been doing so well, so thank you for all of your hard work. Let's keep this momentum going as we start this new unit. We're starting the ready, where it should feel as if it's a throwback of yesteryear. Given the sequence, give a few more terms, state if it's arithmetic, meaning if it's adding or subtracting, or if it's geometric, it would be multiplying or dividing. We've said previously that real G's multiply their money with a geometric sequence, so that's a quirky way to think of it. We might come across some situations where it's neither, meaning it could be adding 10, but then subtracting 3 and then adding 20. It's all over the place, so that may come up also. We'll also write an explicit equation for the sequences. It'll be a good time. So here, we're going back and forth between 4 to -20 to 100 to -50. So it's definitely not arithmetic. I'll tell you why. This would involve subtracting 24. It would then involve adding 120. So that's definitely not arithmetic. We don't want to pick that. However, it could be geometric. So let's entertain that for a moment. We can take hold of our common ratio, which we worked with before. If we have our next and divide it by the previous, and if we keep moving that over and it all happens to match up, then we should be good. I'm going to just entertain this and write out all the fractions. So if I simplify this, -20 over 4 is definitely equal to 100 divided by -20, which is equal to -500 divided by 100, so -5. So if we're doing the explicit, we're going to be doing it for a geometric sequence. I'll tell you that right now, because each term seems to be multiplying by -5. Okay, sound good? All right, so we're now going to be making the explicit. We saw previously that we had a common ratio of -5. I'll show two versions of the explicit. So starting at 4 is my first term. Starting at 4, I keep multiplying by -5, again, my common ratio. And since this is the first term where n equals 1, you can think of this as a day 1 problem. What do you think my exponent here is going to be? Hopefully you're saying n equals 1. And then you can just say that this is a function of n. So let me do a little play-by-play again on what went where. We started with this 4. We said that it went there. Our common ratio of -5, again, ratio, because we keep multiplying over and over, went there. And the reason we picked this exponent of n-1 is because this is the first term in the sequence. It's not the 0 term, so we've got to give respect to that. Take a moment, challenge yourself if you want to try and get the n equals 0 term. This is actually pretty tough, so if you want to try it, go for it, but this one's a bonus. So a little bonus, but if you were going to go to the 0 term and make your explicit, you would have -4/5 multiplying by -5 n times as your exponent. So a little tricky there, but nothing we can't handle. Take a moment, look at all 6 of these and think, are they going to be arithmetic or geometric? Take a moment, pause the video, try these, and you don't need to get the equations just yet, but just think, are these going to be arithmetic or geometric? I have handed you quite a bit on 2. I said it was neither, because if you try to go for your common ratio, none of these are equal, so it's neither. I give you a head start on 3 saying it's geometric. So eventually when you make your explicit, you're going to have 64 multiplying by your common ratio and some exponent. For 4, it's arithmetic, so your common difference I've already given to you. If you need a refresher on this arithmetic, you really just start with your first term, say what your common difference is. And since this is an n equals 1 problem, give respect to that. So there's your explicit for 4. 5's geometric. Starting at 40, you multiply by 1/4 over and over. 6 is neither. See you in the next few problems. I don't think the set's too tough. The key question you need to ask yourself, as we saw in the lab, some graphs might just have dots over and over. Some will have dots and the line that cuts through it to show fractions. The key thing to ask in the set is, can you have fractions of the item that's being described? If you say yes, it's considered continuous, meaning that you can draw a straight line and it would be able to describe the pattern. However, if you're saying no, it can't have fractions of the item, like you can't have a fraction of a person or a fraction of a cat, then it would be discrete and just have dots to make that up. Okay, we'll look at some of these. For every ton of paper that is recycled, 17 trees are saved. You cannot save a fraction of a tree. That would be kind of goofy. So it's discrete. However, in problem 11, you can have fractions of an inch of hair that grows on your head. So in that case, it's continuous. You have some other stories here. I'll leave them up to you to figure out. To conclude the video, we got some old-fashioned one-step equations, solving for x, showing our work too. So I see, and I'll make note of this, I think this is huge with these problems. What am I seeing? I'm seeing 6 multiply with x. So what do I want to do? Well, there's a song called where I think the chorus says opposites attract. What I want to do is the opposite. The opposite of multiplying is going to be dividing. This is kind of working backwards, similar to in the tables when we had to go back to a previous term. If we saw multiplication was happening, we had to undo that with division. We're doing the same thing here. So what are we going to do? We need to really divide both sides by 6. And so although I wrote 6 divided by x, you really want to have 6x divided by 6. There you go. Your 6's will cancel. X equals 72 over 6, which if you simplify it is just 12. So your answer here is 12. I challenge you to do the same types of setups for the next 3 problems. So try 23, 24, and 25. Pause the video, try them, get familiar. Wrote a few different ways down here for the fractions, but up here you should have gotten x equals 50. 200 divided by 4 gets you there. Over here, 50 divided by 3. If you wanted to go towards a decimal, it would be 16.6 repeating. Over here, 25.80 divided by 12. You have 2 as a whole number, and then left over 1.80 divided by 12 is your remainder. Capiche? So with the other problems here, think opposites. 28 is awfully similar. 29 is awfully similar. 27 is also awfully similar. I'll actually do 30. So I see what's happening here. I see a quarter of x equals 2. So I see in my denominator a 4. Up here I have 1. What we can do is multiply both sides by that flipped version of that fraction. So the reciprocal. 4's cancel, 1's cancel, x drops down like it's hot. 2 times 4 over 1. If you really need to see the full fraction work of this, would look like this. Up top, 2 times 4 is 8. 1 times 1 in the bottom is just 1. So our answer here is just 8 for problem 30. I hope that this video was helpful. If you got any questions, bring them to class, say something. Thank you for watching.